Yeah. So we'll be in this chapter. The agenda of this complete session is to make sure that we understand the problems that are being present in the world and how we are going to solve them. This session is going to help us in designing our solutions in a better way, knowing the problems in a better way, and we should be able to design in such a way that basically maybe after 2 years or 5 years still our code supports whatever the new operation comes. So this is the whole agenda of design patterns, and we'll be going more details as well. This session is basically more about focusing on design rather than the implementation. We'll cover the agenda of this meeting, will cover the problem statement, will go with the problem statement, we'll try to find out a solution, we'll try to code that solution as well, and we'll discuss out what are the advantages or disadvantages of every approach that we're going to discuss. So if anyone is not able to hear me, please let me know, otherwise I can start with the presentation. Is everyone is able to hear me? Okay, great. So what exactly is a design pattern? So design pattern is nothing. It's just a proven solution to a problem which is similar to a problem which I'm being solving right now. For me, design pattern is nothing that someone has already been solved a similar kind of problem, and I can, think in the terms in which he has thought, because he has already provided me the solution to that particular problem. So design pattern is basically a proven solution. So when I say he has already solved the problem, I mean to say that he has already solved the problem in the best way anyone could have solved, and that's why it is called as the proven solution as well. The problem which we are solving right now, it may or may not be the exact problem, but it should be similar to some of the existing problems that everyone has solved. Yeah. So, in case you want to stop me at any time, please do stop me at that particular moment as well. In case you have any questions, you can write the questions on the chat. I'll be taking those questions, and it's going to be an interactive session. We are not gonna hurry up, or we are not gonna, we are not gonna miss anything. So make sure whenever you find whenever at any place you find any problem, you stop me and we'll discuss it out. Yeah. So. So one of the computer scientists, which is Christopher Alexander, says that each pattern is basically a three-part rule which expresses a relationship between a certain context, a problem, and a solution. Yeah. So basically, if with whatever problem you solve, that problem is going to have a context. That problem is going to have a problem statement, and we are going to define a solution to that. So basically, patterns are nothing but a kind of solution to a similar kind of problems. This is what basically a design pattern is. So there are many design patterns which are available in the market right now. It is actually goes to 4500 if you go and google it out for the total number of design patterns. Obviously no one can cram, or no one can know all the design patterns. 4500 design patterns in there. By 4500 design patterns, I mean to say there are 4500 different kind of problems are there, which are actually been already been solved, and we can take a reference to them in case the similar kind of problem we are trying to solve. So there are design patterns as well, there are anti-design patterns as well. Sometimes I should there are being some norms, on the basis of them I should not design my problems in a particular fashion, because it can lead to some of the anomalies which do not want to have. So in combined design patterns plus anti-design patterns, there are total 4500 which are being present right now. I'll give you a brief history as well of how it started. Basically it started with the gang of four design patterns. Basically there were four scientists, and they have categorized the problems into three different categories: structure, behavioral, and the creational. And then they have listed maybe seven different kind of problems in each category, and they have given them the solution to them. So earlier, when the concept of design pattern started, there were total 28 design patterns at that time, but after that it grown to 4500. Every time you encountered a problem which you see is a kind of generic problem, people keep on adding the solution to that particular problem in the design pattern list. So that is how the design pattern goes. So we are going to see a particular problem we are going to find out a particular solution to that. This is a very generic problem, and we'll see how we are going to approach to this particular problem. So let's say we are trying to build a cricket application like Cricinfo or Crickbuzz, or there are so many applications for giving me scores and all that, which this application is supposed to tell the users about the current score, run rate, number of overs, wickets, and so much information about the game in the real time. So whenever maybe Kohli has hit a six, I should be straight away notified on my Crickbuzz application, the new application which I'm trying to build, about the latest updated score. Now let's say we have made our two display elements. We have a current score display, we have a average score display. Current score will give me a kind of what is the current score right now, and average score display is going to show me different kind of metrics like predicted score, run rate, or some other kind of metrics which I can derive from the current score itself. There is one more class that I'm going to create. So I'll come to this. So basically current score and average score are my two components, and there is one generic API which is called as the Cricket Raw Data Source API, which basically is going to tell me what is the current score right now. So one solution that anyone can think of is that very basic solution I can think of is in the initially is that every consumer of Cricket Raw Data Source API is gonna call this API every time, right? I'll keep on calling this API every time so as to give me the updated score, and I will show it to my users accordingly. Let's say at every, let's say, 1/10 of a second or a 1 millisecond, after every millisecond I'll keep on hitting this API and will fetch the current score, and then I'll get the updated score and will show it to me. So is this solution being clear to this everyone? Right, I mean, very basic solution or kind of brute force kind of a solution where I'm going to hit my Cricket Raw Data Source API every time so as to get me the updated score. And any, if it is being clear to everyone, and in case you are already you know the solution, can anyone tell me what are the problems that you can have with this kind of solution? Anyone can? Time lagging, okay, definitely. Time lagging, making a API call, fair enough. Performance, can you explain performance a bit more, Piyush? Maybe you can unmute yourself.
Uh, Hello.
Yeah, yeah, it's audible.
Yeah. So actually, suppose you on every 1 second you are calling the API,
Right.
so it will consume the network bandwidth
Exactly.
and other resources may not be useful in that case.
Exactly. It's definitely fair enough. So maybe every time I'm going to make a API
Basically,
call, API calls
yeah.
are always expensive. So every one millisecond I'm going to make a call, it's actually gonna consume my lot of resources, and lot of my bandwidth or network bandwidth or anything like that. Unnecessarily calls. Samitra, can you explain why this will be unnecessarily call? You can go on mute. Unmute, Samitra. Okay, probably I think one user has told us that it will be unnecessary calls. I think he basically what by this unnecessary call, what they meant is that maybe there is no update in the cricket raw data source API, and still I'm making a call to give me the updated score, but and still I'm not getting any new updated information. In that case, it will be counted under the unnecessary call, definitely. And then priority between the current score and the average score module. Okay, so definitely there are a lot of problems that we have figured out using this kind of solution, that whenever I'm going to make a request and response kind of a structure for to my Cricket Raw Data Source API, I'm going to have a lot of performance issues, or the time lag issue, or the unnecessarily calls issues, and so many things. Yeah. So one another solution which I can think of is this kind of approach. So basically, you there is a stadium where the actual cricket match is happening, I'm introducing an intermediator between my stadium and all of my clients, which are current score display and the average score display, which is called as the cricket data. Okay, so this cricket data, yeah. So this cricket data is basically has all the data like runs, balls, etc. and all that. And it whenever any data changes occur between the in the stadium, it will basically tell all the people, all the clients which are there about the latest update on to them. Is this solution being clear to everyone, right? I can introduce the intermediator between my stadium and my all the clients, and that client and that intermediator, which is called as cricket data in our case, is going to tell everyone about the update to this. Okay, so is this solution looks fair to everyone? Okay, so I'll show you. I have created these classes as well and everything. Can anyone you can take 5 minutes of your time and probably can think about create a cricket data class and current data class and average score class as well, and you can write down some of the functions, just a small thing, and then we'll see how it works. So cricket data gets updated every time when there is a change in the run from the stadium. So how they are being updated as well, that also we'll see. But right now you can see that every time there is a change in the stadium, there is a change in the cricket match. Cricket data, you can assume it's gonna be notified. It's gonna be it will be, it can be a pull request as well. It can be a push request as well. Both of the requests can be fine. So just take 5 minutes of your time, guys. Just draw a small two three classes: current data display and average data display, and a cricket data, and try to correlate between them. Try to declare the functions so that whenever there is an update in the cricket data, my both the clients can get the update. Can you guys do it? Is it fine? So we'll take just 4 or 5 minutes. If this is fine with everyone, you can take a pen and paper and try to create these three classes, and a main class as well. Try to find out the relationship between them. I just want to kind of highlight how all these 3 4 classes gonna be interact with each other. So whoever has done, he or she can, you can, tell us the current data score or average data score, description, kind of attributes, what functions you have taken, what are the attributes you have taken, or anything like that, and we can look to that particular design.
Can you hear me?
Yes, yes.
So basically what I am trying to do here is that cricket data will have an instance of current score
Okay.
and average score, assuming that there are only 2 clients available.
Okay, fair enough.
So now in the constructor of cricket data, we have current score and average score,
Okay.
or somehow there will be a setter corresponding to these 2
Sure.
instances.
Sure.
And in return, when cricket data, when it gets notified, it will have a notify method which will call current score dot notify and average score dot notify. And in current score and average score dot notify, we can have a simple kind of bean structure, which will tell us fair enough information like run, wicket, overs. And these 2 beans and these 2 individual classes can act basically upon themselves that what info they need to display.
Sure. Understood. Totally correct. Totally correct. So this is right. In fact, what we are trying to see. I'll show you the structure. I have already coded it. I'll show you the structure. So Can everyone can see my IntelliJ? Is it being seen to everyone? Okay, great.
Yep, I can.
Yes, awesome. So yeah, so as you can see the project structure, I have a average score display, guys, where I have a run rate and a predicted score. I have with me current score display, another kind of template class, presentation layer class, where I have runs, wickets, and over. Yeah, and further I have cricket data. As the cricket data I'll open. Yeah, cricket data have two instances of current score display and average score display, and it has runs, wickets, and overs as well. So in the constructor, as he told, in the constructor of cricket data, I'll be setting up current score display and average score display exactly. And let's say get latest run, I'll making a call to stadium, and let me say I have returned 90. And similarly in the get latest wickets, I will be again making a call to stadium, and let's say I got 2, and again I make a call to latest over, and I got 10.2. Okay, now there is another method called data changed, which in your case it was notified. That is fine. So basically I got the latest run, latest wickets, latest over, and I called two methods of current score display and average score display, which are called as update with run, wickets, and over. Is it being clear to everyone? I mean, this class cricket data is clear to everyone what exactly it is trying to do. Okay, great. Now let's go to current score display and average score display. I'll show you. Current score display has nothing. It has runs, wickets, and over. And it has two simple methods, update and display. Update are just the setters. While getting the runs, wickets, and overs, I'll set it up. And in update will be called from the cricket data itself. And finally, it will call the display method. Display method as just, displaying the runs, wickets, and the over. Similarly, on the average score display, I have run rate and predicted score. Run rate I'm finding out from the runs divided by overs, and predicted score, let's say I'm just applying a small mathematic function run rate into 50 and then calling the display function. Right? Okay, now let's try to run this thing, this particular thing. I already have written a main class where I have created two objects respectively for average score display and current score display, and an object for cricket data, and I have called the cricket data dot data change. Okay, so let me run this. Okay, so yeah, can you see the output? So basically, in the current score display, their runs is 90, wickets is 2, overs is 10.2, and in the average score display, run rate is some 8.82 something, and predicted score is 441. Cool. So this is how the whole thing goes. Basically, I have created a cricket data and two small presentation layer classes called the cricket average score display and the current score display, where I'm basically showing run, wickets, and overs, and run rate and the predicted score. Okay, coming back to the slides again. Right. So everything looks good to this. Now, can anyone tell me, is there any problem associated with uh, this particular thing or not?
I mean, I know observer pattern, so I can tell very quickly that when you want to register a new, let's say, client like current score and average score, in that case, conventionally you have to keep on modifying that class like a cricket data. You have to keep on adding the instance of it, and constructor will also change the way
Exactly.
you are doing.
That's totally fair enough. So basically, one of the very big problem that we are going to have is that in our current data we are holding the references for our two presentation layer logic classes, and tomorrow a new client comes in, then it will be very difficult for me to again modify that class. Ideally, my cricket data, which is ideally not supposed to be changed, I still have to make a code change in that if tomorrow a new clients come, which let's say is supposed to show the some new metrics for related to the cricket match. So that is what I don't want. If a new client comes, a new client should be able to onboard to my system without any kind of intervention. The new client should not disturb the original code which is running, because if he disturbs the original code, then I will have to pause the, I have to make the code change, I have to deploy the new code change, and that can result and that can impact the already existing clients, because there can be deployment time in which the other clients which were already serving with the previous code, they will be not be able to see get the new code. So these basically cricket data and the display elements are tightly coupled, which I don't want, and this is why definitely this is not a good design pattern or practice I should be having it. So let's try to solve this problem. So can you think of some, can you guys think of something where we can break down the coupling between the cricket data and the display elements like cricket data score and the average data score? So these are basically all are the kind of, whenever we try to create any solution to the problem, we definitely think whether the solution we are creating is scalable, is it being real time, is it easy to manage, is it is it resulting with lots of probably fatals or any such tickets or any all those things. So these are different kind of metrics we definitely have to look forward in every kind of design, or every kind of solution we are trying to propose. So so uh, so we will try to, we'll try to find a better solution than the previous thing that we have just discussed, where cricket data and the other two layers, which were cricket data score and the average data score, were tightly coupled. We'll try to find a better, we'll try to create, we'll try to decouple them. So just take 2 or 3 minutes, and if there is a solution to that, we can discuss it out. Okay, so is anyone can help me in decoupling the two layers?
Yeah, exactly. Here, average data is score, and whatever else is acting as a notified system corresponding to cricket data.
Mm-hmm.
So since all of those classes are acting as their own in certain term, that they are kind of here observer pattern, they are kind of observing the things which
Yeah.
cricket data has to supply. So what we can do is we can ask them to implement an interface,
Mm-hmm.
and that particular interface will have suggestions from the cricket data to pass it in the method, and all of them can work independently, rather than, and we don't need to provide the exact instance in the cricket data.
Okay, sounds good. Yeah, fair enough. So I'll show you the, yeah. So I think you're trying to tell this thing. So basically, this is a classic example of observer design pattern, and this is a very classic class diagram for any observer design pattern, where we are going to have a observer interface. We are going to have our concrete classes like first observer, second observer, who are going to implement this observer interface. Every class is have to declare a method called execute, basically, and there will be an observable kind of, which we also call as subject, which will basically hold the list for all the observers, and it can add the observer, it can delete the observer, and it will notify all the observer. In the notify all, basically we are going to call all the observers in the observers list about the new data. anyone can call Anyone can add to the observer list using add observer. Anyone can delete themselves from the observer list using delete observer. So this is what the, kind of class diagram, or the low level kind of low level diagram for the observer design pattern, which you are going to see in every this similar kind of problem. So let's try to see. Yeah, so let's try to. I'll show you. Just a second. Let me show you the. Yeah. So can you guys see again my IntelliJ? I hope everyone is able to see the IntelliJ, right? The editor, right? Okay, great. So as you can see, I have one more class called as average score display observer. It is almost similar to the previous class. Only difference is it implements another interface called as IObserver. As we have told in the previous class diagram, IObserver has a method called notify. So every of the implementation class which is going to implement the IObserver has to implement this method. So average score display observer, which is implementing the IObserver, has to implement the notify method. Similarly, current score display interface, current score display observer class is also implementing the IObserver interface and has to implement the notify method. Okay. Now, if you see the notify methods of these classes, they are basically, there is a map, data map, which is having all the data which is coming from from my API. You can say my stadium. So I am going to get my runs, wickets, and over from them using datamap.get run, datamap.get wickets, datamap.get overs, and then I am again going to call my update function, which I was calling directly in my cricket score display earlier, and further display. Similarly, in the average score display observer, in the notify method, again I'm going to capture my runs, wickets, and scores, and again I'm going to call the update function, which is further going to calculate the run rate and the predicted score using the runs and the wickets, and is going to call the display. Is it clear? Now let's see one more class which is very important class, which is called as the cricket data subject. Cricket data subject, which in our class diagram which was there, it is actually having having attributes as runs, wickets, and overs, and most importantly it is having an array list of IObserver. Now it is implementing three functions called as add observer, which is also called as register, delete observer, which is also called as deregister, and notify observers. I have written another functions which I'll tell you what those functions are. Notify observers. So basically, add register function is just adding the new observer to the list. Similarly, deregister is deleting any observer from the list, and notify observer is creating the data map and calling the notify function of every observer in the observer list. So when notify function of every observer will be called, internally it will call the update function, and internally it will call the display function of each observer, right? Now then I have my methods called latest run, latest wickets, and the latest over, which I'll give it a call to my stadium API or anything like that, and I'll do that. And data change for observer is also doing the similar kind of thing. So this is what the whole thing is about. If you see this kind of now let me run, first of all I'll show you how it basically runs. Let me comment it out the previous one which we have, and let me uncomment this one. So if you see, I have created a object of cricket data subject. I have created a client which is average score display, and which is already implementing the IObserver interface. I am calling the register function of average score display for the average score display, and I'm again creating a current score display observer and calling the register function for the cricket data subject. So now what will happen when I created the cricket data subject, a new array list for the observers must have been created. After that, two observers, which are average score display observer and current score display observer, must have been added to that particular list. Now I will be calling subject.data change for the observers. Now this subject.data change for observer is nothing. Basically it captures the runs and then it calls the notify observers method. which will internally call the notify method for each observer. Right now, let me run it. Okay, now if you see, we can see the similar kind of output where current rate and the predicted score and current score display is also giving me the similar kind of data which was coming earlier. But the kind of advantage that we have achieved from this kind of design is that I can add or delete the client at runtime. For example, let me say I don't want my current data display, current score display don't want to be anymore be don't want to be there at anymore, and it want to deregister himself. So I called the subject dot deregister, and I called current observer. Now I have now again the subject dot data change is being called, and now if I'll run, you will see only average score display. So initially average score display and current score display is being called, and after that only average score display is being shown to you, not the current score display. Right? So this is how it's gonna be there. I can add my client, I can delete my clients at any given particular moment. I need not to be change my entire logic at any given point of time. So this is the advantage which observer design patterns brings onto the table. So I'll proceed further in case you guys don't have any kind of questions with the classes that I've created. In case you have questions, please you can tell me.
I have a question that why exactly the execute method is getting a map kind of a structure. Is it a kind of is it a kind of classical way of doing it, or we can use bean or anything else?
Execute method in the current data subject are you talking about?
Exactly. So there we are passing it as a data map.
Right.
So here you see in the signature you have not added any kind of parameter in execute.
Right.
Okay.
So
But there you
yeah. So basically, so this is just a class diagram. This is a kind of classic execute method, but many of in your application you will be having the data which needs to be passed to every of the client, right? So that is why I have taken a data map. It that can be a map, that can be just a string, or it may not need to be any kind of a this thing. It can be a boolean variable, any kind of a thing. It's just a data which needs to pass from one source, which is getting changed every time to all the people, all the subscribers who are looking out for that particular change. And that's why I have used my data map, which was actually constituting runs, wickets, and overs. And because my current cricket data, current score display and average score display needs to show the scores at runtime. Now when the score has changed, I need to be notified, okay, the scores has been changed, and that's why I passed the data map, because data map will contain the updated score. So it's a kind of, it depends on your application to application. If you don't have any parameter, if you don't have any data that needs to be passed to your observers, then you need not to pass any of the parameter in the execute function. But in case if there is any live data, real time data, then you can have. So it depends on your application to application. Does that answer your question?
yeah.
Yeah.
Yeah, I was just thinking, can we use rather than string of a string as a map, can we just simply use a bean class which consists of these three wicket, overs, and run? So,
Yes,
will
definitely.
it not be better than this?
Definitely, yes. That is also one of the better solution. I'll say you can in fact create a kind of pojo where you are or a bean where you have the run or wickets or over, something like that. Rather than creating the attributes like runs, wickets, and overs in the cricket data subject, you can have an instance of that particular bean, and in that particular bean you can have the attributes like runs, wickets, and the overs, and you can inject that, or you can using Spring or anything like that, or you can have a reference directly over here. That will be more better, I'll say.
Okay.
Okay, so Piyush has asked a question, that is your subject class is observable over here? Subject class is actually the person who is telling the updated information to every of the observer. So yes, subject class is observable as according to diagram. It maps the observable in the diagram maps to the cricket data subject in the code. Does that answer your question, Piyush? Okay. Okay. So let's
No, I have one more thing
sure,
that
sure.
rather than this subject having like this, I mean, will it not be again a good idea if we can have simply like observable is an interface,
Uh,
okay, which have notify all and all those kind of things, and add
observable.
observe and delete observe and any kind of observable, it simply, implements it.
So
Will it not be
observable.
more fine grained design?
So observable need or need not to be an interface. It can simply be a plain class as well. Can you tell me any what you say?
Okay, so like there is a complex system. So here you are designing a crick subject area, and let's say there is one more guy coming and saying add subject area or
Yes,
whatever, add subject. So in that case,
definitely.
that guy will have correspondingly, observable things. So
Makes
let's
sense.
say the whole system is comprised of multiple kind of observable and observers.
Yes.
So if we have one interface like observable, then what all individual classes
Mhm.
which are observable, they can simply implement this observable interface and can
Definitely.
implement all those methods on their own.
Definitely. If you have more than one observables, then you should definitely have an interface called as observable, and classes like cricket data subject should implement that interface with methods like add or delete or notify and an observer list. Definitely, I'll definitely it's a good solution. Yes. So the example that I've just shown you is kind of very basic example right now. But if you have a complex system where you have more number of observables, then definitely it makes more sense to have an interface.
Hello.
Yeah.
Yeah. So I have one question. How this observable design pattern is similar to that producer consumer? Is it part of that only, or it is somewhere different from that?
So it is actually somehow it is similar to what producer consumer problem does. So you have a producer and you have a consumer, and it actually does the similar kind of a thing only. In fact, this design pattern has actually been derived from particular producer consumer problem itself. So it is the same thing which producer consumer problem does. You have a producer, you have a different kind of consumers, and everything will be given to producer. The only thing which over there is difference is that the producer need not to be there is a what producer consumer problem tells is that I will keep on producing something and consumers are in the queue of taking that particular thing, right? So so I need to maintain the buffer. I need to maintain some queue where producer is uh, adding the resources and consumers are keep on taking the resources, and I need to know whether the that particular queue is have all the don't have any entry or not. So in this way it is similar. It is not similar to this problem because here we just need to pass the data whatever is coming to the producer to all the consumers. Simply pass on all the data which is coming to the producer to the consumer.
So again, there is one term like PubSub,
uh,
publisher subscriber.
it is actually the same thing. It is publisher subscriber only.
But there should be a intermediator between the PubSub. But in case of observable design pattern, there is no intermediator.
In case of intermediate as in, so you have
Like
yeah, go on.
like you are telling that buffer should be there. So the producer will put to the buffer
that
and
is,
consumer will pick the
that is what
buffer.
I'm trying to tell you.
Uh,
You need to maintain that buffer, that whether your buffer has some entries only, then consumers will be given the resources. Otherwise wait for the resources to be pushed into the your buffer queue or anything like that. But here whatever you have, you just straight away pass on to observers. You need not to keep yourself it. Whenever there is an update on the whenever there is an update on the on the producer, you just give it to all the consumers. So all
Okay.
the consumers are basically, it is actually being evolved from earlier. I was making a direct one again repetitive call to producer. Is there an update to you? Is there an update to you? Is there an update to you? And when there was an update, I'll get that. But here, I am not suppose as a consumer, I will not make any call to the producer. Producer, whenever there is an update in the producer, it will directly give it to me. So that is the
Okay.
difference in a way.
Okay.
Okay, so okay, let's proceed further. So this is basically the same kind of a thing that we have just told right now. So there are definitely some advantages and some disadvantages of the observer design pattern as well. You basically get a loosely coupled systems. You tomorrow the if there is any client which wants to onboard to the system, it can easily do so, and we can reuse the subject and the observer classes independently of each other. But there is one very important, kind of small disadvantages which sometimes comes. In fact, I have seen when I have observed my when I have implemented the observer pattern, sometimes memory leaks occurred when you implement the observer pattern, and that is also called as the lapsed listener problem. I'll explain what this problem is. So assume that the one of the client makes a call to deregister himself. So he will call maybe a subject dot deregister and the object of itself. But somehow this API call gets failed, and client is still in the observer list of the subject, and subject will keep on pushing the updates from the main server to all the clients. And it because that particular client which was trying himself to get deregister is now acting as a dangling reference in the subject observers list. So in that case, we have to make ourselves very clear. We have to design our systems with maybe time to live, or maybe some more fault tolerance methods, where we will check whether this particular all the clients are still alive or not, they are being present or not, whether they are actually trying to listen to the updates or not. In that case, we just to get rid of this kind of problem, we also incompensate our more fault tolerance method as well in our observer design pattern design. Okay, is it fine, or does it make sense? Okay, so yeah, so next I would like to just a second. Yeah. So basically, when to use this pattern, you will definitely be using the pattern where you have to listen to the update directly. It is heavily being used in the GUI toolkit and the event listeners, because whenever there is an event change, you have to keep on listening to that particular event, and you will be seeing whether there is an update or not. Social media, RSS feeds, subscriptions, and all of these places are being used. Whenever you install any application on your mobile, whenever there is an update to you, you get the push notifications and all those things. In all those places, this pattern is being used heavily, and that is why it is one of the most important design pattern for designing any kind of applications as well. Yeah, so that is what observer pattern is all about. We'll go to another problem, we'll go to another kind of design pattern as well. In case anyone has any doubts with respect to observer design pattern, please tell me, otherwise we can go ahead.
Hello. Yeah. Can you once show the class, that subject class?
Sure, just a second, I'll show you. Cricket data subject, right?
Yeah. So who is calling that register method?
Who is calling the register method? There is a main class.
Okay.
From here
Okay.
I
So
have to,
in
sorry.
yeah. Okay. So in main class we are telling the whoever is interested in that subject.
Exactly, who all are the clients.
Okay.
Is it
Okay.
fine?
Okay. Okay. Yeah, thank you.
Okay. So yeah. So I'll again. Can we go to the next problem statement, guys? Is it fine?
Yep.
Okay. So there is another problem statement that I want to highlight over here. So let's say we have two systems. Let's say we have two systems. One is the payroll system, like you must be receiving your salary slips from your companies, and generally the companies which monitors the salary slip or makes your salary slips are called the payroll systems, and they are generally the outsourcing companies. For example, there is one company called Allsec which basically takes care of all the payroll systems, and generally there are other, and there will be so many other companies like Samsung, Amazon, Microsoft, who will be clients to this payroll system. So payroll systems wanted to get information from companies in the form of their object, and companies all the client companies like Amazon or all these companies have the information about their employees in their their object, kind of a thing. So basically we have a payroll API which wanted to get some information related to employee, and in our systems we will be giving the employee information in our employee. We have stored the employee information in our employee kind of object. For example, my employee object can have my manager, my manager, my senior manager, my organization, my name, my anything like that, my team name and all that stuff. But payroll system only maybe needed to know what is my organization and what is my name. That is what all information it needs. So in these kind of systems, when we need to talk with third party APIs, we need to adhere to their object systems only, and we need to make sure that my object needs to communicate to the payroll system object in a better fashion. I should not pass unnecessary information to my third party object. So in these kind of systems, these are the very important kind of problems that we have to solve everywhere. So we will be passing our employee information to payroll system using an API method called payroll ru update, where the object that it will accept will be the payroll person. It will not be the employee. Employee is the object for the, or it is the class for the companies like Amazon or companies like this, whereas payroll person is the class for the Allsec company. Is the problem statement is clear? So basically, in this kind of thing, we want to communicate with these two things. So let's say we break down this example to four kind of things. There is a client which for the class which we are writing, there is a adaptee. The class we need to use but can't because of its incompatible interfaces. Like for example, the payroll has a different interface, and my company has a different interface. Every adaptive will expose a method called update, where it will accept the object of that particular the type only, a certain type only, and client always needs to request a method called update, where it will pass the employee. So we need to interact the employee object with the payroll person object. That is the whole problem is all about. My employee should communicate all of the information to the payroll person, whatever it needed. So this is what we generally deal with. So here, one of the very important design pattern, which is also called as the adapter design patterns, comes into picture, which is actually going to help us from saving here. So basically, what we do is we basically introduce a new interface called the target interface, which the adapt where what we are going to do is, which actually is going to convert the employee object into the payroll object. So it will just, whenever a new client comes tomorrow, it will directly change that client object to the payroll person object. So this is what we do. Even if you, the adapter, why it is called adapter, because even if you do like, you have the USB adapters or something like that, your laptop will accept different kind of things, but your mobile will accept different kind of voltage. So adapter in between them will convert, will try to communicate between those two, and will try to communicate, will try to set up the right voltage which mobile is needed and which computer is needed. So that is what the objective of adapter is. It will try to convert the employee data to the payroll person object, so that the payroll person update method can be called. So it, you can think of it just a kind of wrapper right now, right? Basically it's a kind of wrapper written on top of my employee object, where it will try to convert my employee object to payroll object. But it may not be a wrapper every time. Sometimes we may, it actually provides an abstraction as well. It actually provides, it actually has to, it actually helps me to, implement a very important principle of any design, which is called as the open close principle as well. There are basically 5 design principles which are abbreviated by the term solid. One of them is open close principles, which basically says that software entities should be open for extension, but they should be closed for modification. Tomorrow, if my new, let's say there are 3 clients right now, Amazon, Microsoft and Google. If tomorrow my Facebook comes, then only my new, whatever was my adaptive was there, that will, sorry, whatever the adapter was there, only in that adapter I will need to make the code changes. Neither the client, neither the actual system I'm going to make my code changes. Further, if tomorrow my payroll system has changes the method, that now it will not update, now it will not accept the payroll system object, it will, let's say, accept the some payroll system one object, then also I will just need to make the changes in my adapter, and the clients will not be impacted by that. So that's why it this adapter helps me to achieve this kind of, this kind of full proofing or future proofing to the code changes which can come tomorrow. So there is, I don't want to go into the code details right now because we are already running short of time. I want to spare some of the time to, for the questions as well. Yeah. So basically, concludingly, if you see, we have just written a wrapper class which helps me to achieve the open close principle by, making change in the adapter class only, and not in the client or the main payroll system class. And this is how my design should be. I should be, if tomorrow any of the both the system changes, I should do the minimal change, so that my existing people who are already communicating to each other should not be impacted. So this is what all I had right now. I hope you get some of the idea about it. I'll definitely encourage you to look into the design patterns, because these are very much important in any kind of, industry, or whenever you are coding for any kind of designing any kind of application. It helps to communicate between the objects in a better way. It helps to design our system for the future. It helps to, there are different kind of design tenets which it helps to achieve, and that's why there is a lot of importance of design patterns in industry. So that's it. I'll open the session for Q&A. If you have any questions, please let me know. Let's discuss them out.
So in the last part, which you just said right now
Yeah.
about the adapter,
Mm-hmm.
I have a question that what about, say, one of the companies called X has 10 features in their payroll system, and we have probably considered 15 of them, like in the payroll system. Then there is another company which comes up with 20 features. So how is that catered?
So
Features as in like you can understand it as maybe database columns or something like that.
okay, so let me rephrase your question. I think, yeah, what you're trying to say is, let's say payroll system has five. It needs five attributes, maybe employee name, employee first name, employee last name. Uh, let's say
Yeah.
it needs just two attributes, and there is a company called X. In the object of that, it has five attributes: employee name, employee first name, employee last name, or employee name only, let's say, and employee team, employee manager, and some employee age or date of birth or something like that, right? And there is another company called Y,
Mm-hmm.
which further has similar kind of attributes, or maybe more than this kind of attributes. So how we are catering to it? Is it my right
Right.
understanding?
Right.
Right.
Yeah.
So
Like there are extra features in company Y,
right,
which is not in the payroll system.
right, exactly. So basically what I am I need only two features, which is first name and the last name. That is what the payroll system needs. So my adapter is only responsible
Okay.
for getting the fetching the information of first name and last name for whatever it is being passed to him. That is his only duty. He just need to get the X object
Okay.
and fetch the first name and last name, and there should be first name and last name in the X object, otherwise it will not work.
Mm-hmm.
And similarly, it will fetch the first name and the last name from the Y's object as well,
Okay.
right? And then it will pass to the payroll system. So its objective is to create the payroll system object from the objects of X and Y, and X and Y already have that particular information. So payroll system will always be subset of X and Y objects, I'll say.
Yeah. But there is some extra information which is lost, is what I'm saying.
Yes.
Maybe address is not in
So that
the
is what,
payroll system.
yes, so that is what we are trying to solve over here. If you see, I don't want to pass the address to the payroll system. I don't want to do it. Why my payroll system needs to look into the employee address? That is not acceptable. It only needs whatever it needs. I'll pass him that thing only. Now adapter
Okay.
is sitting in between payroll system and company X. Company X,
Mm-hmm.
whatever data which is there with the company X, I should not pass any of the company's X data which is not required by payroll system. And that is what adapter is doing. The
Okay. Yeah. Understood.
right
So
information
is
is not
there
lost.
is the extra information to be presented by the payroll by the adapter itself?
Extra information like so that is what I'm saying. Adapter, the payroll system will always need a lesser information, which is what present in the X or Y.
Okay. I understood what you're saying.
Right, okay, so I hope it makes sense. Okay, so I'll take the next question. I am new to it. Any book recommendation? Yes, somebody replied head first design patterns. Yes, definitely it's a good book. It's an awesome book to start up with, but there are a lot of other books as well. But to be honest, generally, basically these design patterns are nothing but the problems that have occurred to somebody, and they have presented a solution. So I'll say keep on get more design, get more of the problems, try more of the problems, you will try more of the solutions, you will see, and then you will try to see whether your scalability, your all the design principles which you see are being met or not. There can be more than one solution to a particular type of problem. Head first is definitely one of the start to the book, but there are a lot of other books as well. I'll post a kind of, I have a blog with me, where a kind of I have the sequence of book written in which you should read. That blog is not being maintained by one, by me, it is being maintained by someone else, but it very clearly dictates that this is the some of the kind of the books which you should read if you have time in the particular order, and head first is, comes on top of them. So I'll share that blog link with you. I don't have right now with me, but for the timing you can definitely go with head first.
Also, can this the slides which you were referring
Sure.
for the presentation, are these also going to be available somewhere?
Definitely, definitely. I'll share the code, which the package that I have created, as well as the slides with you guys. I hope they'll be helpful to you. I'll share both of them together, and we will also
Okay.
share.
Yeah, am I audible?
Yes, yes, you are audible.
This is Reena here.
Yeah. Hi.
Yeah, I wanted to know what is the need for writing this observer pattern when Java itself provides you an observer and an observable. I mean, what is it different? How is it different?
So, Veena, first of all, this observable came into Java 7, if I'm not wrong.
Yeah,
And
yeah, yeah.
right, so before Java 7 as well, this problem was there itself. And somebody has coded this kind of solution, and they have needed they have basically provided you the already implemented classes which are observable and all these things. But I'll say so basically I'll say Java already had linked list class, right? Then why you study linked list chapter in your maybe data structure course or maybe in your curriculums? It's basically tomorrow I can be a Java, I can work for the Java, and I can be asked to write a similar kind of class, right? So I should know what is going underneath the observable. I should definitely understand what exactly observable doing is doing behind the scenes, because only then I will able to extend it. Only then I will be able to use it in a better way, right? We
Okay,
always
my question is Java itself providing some of the loopholes that we might miss if we write an observer pattern by ourselves? I mean to say some memory related issues. Is it taking care of? Is there a difference that way?
Yes, yes, definitely. You can like I have told, there is a problem with the memory leak that I think that comes with the Java observable thing as well. Probably you can override it with your particular algorithm of fault tolerance, of where you will be querying each systems for their TTL, and if there is more, if there is any client which is not responding, you will flush that client out from the observers list. This is another kind of topping you can add to the observers pattern which is being provided by Java.
Okay,
Yeah.
thank you.
Okay, so
Yeah,
something
I
was
got
supposed to
one more
ask.
question. Am I audible?
Yes, yes.
There was someone who asked this question, like if there are 2 or 3 clients corresponding to that payroll,
Uh-huh.
then what you said is, then my point is this: will the adapter pattern exist one-on-one between? I mean, can multiple clients use the same adapter pattern? Like she was saying, there is some much more information in the other client rather than the first client.
Mhm.
Okay, then adapter pattern takes the object of one client and converts into the target object, if I am correct. Then
Yes.
what the issue here is, can we use the same adapter pattern to take multiple kinds of objects, multiple kinds of object as like a
Provided,
Facebook object, Google object, everyone is providing an object, then can we simply have an object class
no. Provided they
corresponding to
implement
the client and convert it in there?
provided they implement the some common interface. They have to implement a common interface. So
No,
Google,
but that common is there. But my point is this: let's say it's a Facebook payroll, it's a
sorry.
Google payroll.
Uh,
So all of them have a different kind of thing. So can we convert them into final class using a single adapter, or we need to use one-on-one for multiple?
so that is what I'm saying. You need to you the best shot that you can take is you can use you should have a one adapter for one your Google system. But if supposingly I am having Google, Microsoft, or other companies, they all implement the same kind of interface. They all these companies, the objects can implement the same kind of interface. Then I can use the one adapter only for all of them because they use the same kind of interface. But in
But
best,
what if they don't use?
then you will have to do a one-on-one mapping. Then you will have to do the one-on-one mapping. So you will have to write the adapter. So in that case, the adapter adapter best part will come into the future. Like tomorrow, if payroll system changes your some portion or something like that, then you will have to make changes in your every adapter.
Mm-hmm.
But if Google changes something in their this thing, if Google changes something in their object, then you will have to make change in only in the one adapter. and it will not impact the other clients.
Okay, so it's better advisable to use one-on-one.
One-on-one, provided they don't implement the same interface. But adapter, it may be possible that the objects can implement the same interface. It may be possible. If they implement the same interface, then you can use the same single one only.
Yeah.
Okay. Okay. So that's it. I hope you enjoyed the session, guys. We'll be coming out with more sessions as well. We'll come out with more other, maybe not on design pattern, maybe on some other session, maybe on other topics as well. How to write a better code, how to structure a code, dealing with legacy codes and all of them. Yeah, so you can find more information, or you can mail me out at info@techboost.in, this thing, or you can visit our website as well. You can mail me. I'll definitely be super glad and happy to answer all of your questions. In case I missed anything, please do let me know. I'll also, will try to learn it out. See you guys soon. I hope you like the video.
One last question is
Sure,
this.
sir. Sure, sir.
Is it a kind of series which will go on?
Sorry, I didn't get your question. Sorry.
Is it a kind of design pattern series which you are hosting, or was it just a glimpse from your whatever Tech Boost consultancy?
Not exactly a kind of series, and not exactly a kind of links on Tech Boost consultancy as well. These are kind of the random topics we take. I mean, it's not a kind of sequential order, or that's why I said it's not a kind of part of any series. We do have a design pattern course as well, but these are sessions I just take, maybe just to share the knowledge, just to keep you posted, just for the awareness purpose. It has nothing to do with any kind of public propaganda or anything like that. There is not a series.
Okay, cool.
I didn't have any sequential out of the videos. Sorry for that. But we are, but we'll try to make it out. I'm not sure when it will happen. Okay.
Okay.
Okay. Great, guys. We are on time. I'm glad to be on time. Okay. See you guys. Hope you have a good day. Happy Sunday. See you soon. Bye bye.